Hey everyone, so welcome to our new episode about how we're writing documentation. Let me jump right into how we actually do that. So if you guys will head over to Flamingo Stack is our main repository of the company. Because of the open source nature of the business, most of the repositories are public, but some of them are private. But I'll focus on the public one. OpenFrame in a nutshell is a unified data, API, and deployment layer on top of existing open source tools to make them easier to consume by IT teams, IT and security teams. So what happens is that every open source tool that we vet and we add into our product, we create a fork of it and deploy some of our security standards, etc., and also add Terraform and other type of scripts in order to make it function inside of a larger cluster. So for example, we use a tool called OSQuery, which is an endpoint management tool. And OSQuery, as you see here, that's a fork. Many times we kind of take our time until we sync with the main repository, but you can see here that that's our fork of OSQuery, and if we'll check in the product itself, you will see that once we get our product deployed, one of the agents that we deploy is OSQuery. So that's our version of OSQuery, meaning that we build the binaries, we change everything. Now, we do that not for one tool, we do that for a bunch of tools, and in order to make things like license, contributing guidelines, source code documentation, but also tutorials unified and scalable, because on every code change that you do, you probably should scan the documentation and the tutorials. We built multi-stage AI agent that helps us write this documentation in a scalable manner. It's also pretty easy to add it to new repositories as we add more and more along the way. And the nice part about it is that we also built a way to project it on our website. Let's go to two of our main repositories. We have OpenFrame OSS tenant, which is the actual tenant that we use, this one. And you see here that we have YouTube and we have a bunch of things that we have here. Also our license. The docs folder that you will find here is a projection of what you will find if you'll go to Knowledge Hub. So right now I'm on OpenFrame CLI, but we also have OpenFrame platform. That's one-to-one what we saw before. So if we'll go back here, you see that's exactly the same. So we have syncing process between our repositories and not one, like we have more than one repositories that are getting synced directly into our website, and all of it is working as a real knowledge base hub. We also index that for our AI agent. So if you'll ask the AI agent questions about what's going on here and the projection that it has here, it has RAG and it can reference back to here, and you will be able to receive direct links into the knowledge management. So this is kind of like the last stage. So imagine that we have the first stage is generating the documentation with AI, creating a pull request inside of the repository, merging the pull request, pulling the data to our backend database that is basically what we're seeing right now, index it as a RAG, and then we have a complete end-to-end process that not only builds the documentation, but makes it super, super easy to distribute and consume by our users. So let's head over to how do we actually create the documentation. So here we have 5 repositories. We can add more. What's that? So each one of those is a different repository. And if I'll click here, you'll find all the different parameters. So you can configure here the name, the repository, GitHub details. We'll talk in a second about this. This is the branch that the workflow is running from, because the way it works, it runs with the GitHub Actions workflow. But then we have some secrets we need to inject into the workflow, things like Cloud API key and things like that. So we cannot send it as workflow parameters because then they become public. So we have to do it through secrets. And then we can also configure dependencies. So OSS tenant is heavily relying on a lib called OSS lib. Inside here, you can reference different repository and chain it to each other. You can reference them here. You need to add a repository in order to reference it. So you see that the repositories that we have here are basically the repositories that we saw on the previous screen. And you can also configure which type of connection is it between those two repositories. Like, let's say here we have OSS tenant, which is getting deployed by OpenFrame CLI. So we can tell to the AI agent, listen, That's the core code base, but there is a CLI tool that you need to reference on the documentation. That reference can be a library, API server, SDK, documentation, whatever, and you just put here all of the different things, the different parameters. YouTube integrations, so you can configure here YouTube integration, and then the AI agent, once it's running and writing up stuff like README and tutorials, it will try to look for references inside of the YouTube account that is attached to it. And if it will find it, it will auto-inject it into the documentation. Here we have free text that we can add, and that will get injected to all of the stages inside of the documentation. So how does it work? Once we add new repository, the repository will ask us to create a PR, to create a pull request. And inside of this pull request, we're going to have a workflow file. You see, it's only one file. And this workflow file has everything needed documentation to run. Now, once a pull request is getting added into this repository, we will have new GitHub Actions option. If we'll head over here, we'll have here Doc Orchestrator Pipeline. This was created by that workflow that I just added. And once I'm doing it, I will also need to sync the secrets. So if we'll head over to here, you see that was added by this dashboard. It was not added manually in any way. Once we have this up and running, we can hit, and if you remember before, we also had this branch to run workflow from. So if for any reason you want to change the branch or let's say that we merged the workflow file directly into main, we can just use main. So you can also change the workflow that it's running from. Most of the time, it's being detected automatically. The system will check if the workflow file already exists. It's not going to be asking you to add another pull request. And once we're going to hit run, what's going to happen now is that the workflow is going to get activated and the GitHub action workflow is going to start running. The way it communicates back and forth is with webhooks. So a new GitHub action will start running, and then it will inform us. You see that it's informing us that it started. And if we'll click here, we will see the workflow and the way it's getting executed. So see, it downloads a bunch of stuff. Execution of that workflow is 3-stage execution. We try to make it as easy as possible for the AI to generate those stuff. So here, this is probably the heaviest step. We run through every file in the repository that is code, meaning that if it's like a configuration file or something similar to that, we're just going to skip it. And we check whether it was indexed before. If not, we're going to send it to Claude. You can also configure each module here, module clustering. You can configure which module you want for each of those steps. You can also configure where the files that the tool is generating are going to be written to. So you see here, reference architecture analysis will be written into this folder, and diagrams will be written to this folder, etc. So everything is really, really configurable. I'll explain about the different stages of the GitHub Actions, but certain stages require very large context window, and certain stages require deeper thinking. That's why it's fully customizable, and that's why we're using OpenAI for that and not Claude. So you saw that it just went through all of the files in the repository. It figured out which files need to get updated. So you see here, it generated a few of them. So the first stage is writing inline documentation for every file in the repository. The second part, we're using a tool called CODWiki. This one. CODWiki is a tool to evaluate and create documentation for large code bases. We heavily extended CODWiki, so we created our own fork. We also extended it to be more flexible in terms of which LLM modules it's accept. Here you can see CODWiki. That's also our fork, so we're not using the regular one. This is Python. Google was supposed to release something similar to that as a CLI, and I added myself to the waitlist, but it didn't happen yet. The way CODWiki works is that, maybe if it's actually running here, we'll see that it has few stages. Let's go to a pipeline run that already finished. This one is a Java, mostly Java code base, so it's definitely ran here. Let's go. Sorry, this is SAS standard. So we head over here. We go to Actions, Doc Orchestrator Pipeline. And that's the latest run. You see that it took a while to run because it's a pretty extensive process. So here's the CODWiki part. It's deployed the Python and then it configures everything. And then what I wanted to show here is that different stages inside of CODWiki require different capabilities from the LLM model. So the cluster model is GPT 5.2. And the reason for that is that what happens in the first phase of CODWiki, it scans the entire directory and write to himself small comments about what each of those code bases or folders is referring to. For example, if it identified something like oath, it will know that it's related to authentication and things like that. And then it clusters everything. So you see it does multiple clustering, and then it starts to go through each of those folders and each of those clusters and generate documentation to it. We will see the result in a second. So you see it figured out that it has 21 components, etc. The nice part about it is that it looks at the code base, or if you define also dependencies inside of it, it looks at it from a hierarchical perspective across everything, all the folders. So if you have authentication class in one folder and then another authentication class in a different folder, it will aggregate both of them and will figure out contextual analysis of everything into one file. So if it builds a file on how OpenFrame authentication works, it will aggregate all of the files from all of the folders. So that runs, we'll show in a second. Then we use to generate tutorials and things like readmes and things that are more user-facing. We use a tool called Vault Agent, and Vault Agent also have a multi-stage process inside of it. Vault Agent is a multi-agent system specifically designed for documentation, so we use that as well. And you see that it's also extracting the diagrams. It's also create mermaid diagrams. We'll see it's beautiful diagrams. And then it creates, and you see that after every stage, it updates the pull request, because what happens is that all of this work is being created as a pull request. So you see that it has all the files. Now the pull request, and this is documentation, how it looks like. The reason why we keep on updating the PR along the way is some of the stages are pretty expensive, right? Like if we run through all of the files in a certain repository and we send it to AI to index, we want to keep this work across different runs. That's why we have this PR. So this is kind of how the output looks like. And then once we merge it, and by the way, it's not only the docs, it's also make sure that the license is correct, that we have all the security standard, contributing guidelines, etc. Even the links below, everything here is defined and generated by the AI. That's how it looks like at the end. So you just merge it into the latest main release, and then you have this beautiful documentation. If we head over to docs, you see that this was all, you can actually see that that's 4 months ago. So everything was generated by this agent, and those are the clusters that I was talking about before. So data stream and Kafka, it basically went through the entire project in order to figure out how Kafka works and how data stream works. Same with, actually, I was talking about authorization and authentication. Let's take authorization here. You see here, beautiful diagrams, and all of that is also reflected on our website. So you see here you have architecture, and that's actually with our styling, etc. And then even if I'm gonna ask here, how do I self-host, that have everything that I showed before already indexed, right? So you see here that it referenced me back to the documentation. So if I'll click here, if I click on that, it will take me directly here. Let's let it finish, and you will see that like those references are hard references inside of the chat, but the AI is also telling us what did I rely my answer on. And we can even do ask. And then if you ask about a specific document, the AI will analyze this document alongside the RAG and everything. And that will be, it also scrapes videos automatically. So imagine like an entire system that is completely feeding each other. By the way, our content management and our marketing operation is also writing things automatically into YouTube. So that's a self-feeding process. You feed something to YouTube, then the AI pick it up, and then it gets directly ingested by the knowledge hub management. Yeah, I think that's pretty much it. We covered most of the stuff, but just kind of our way to show you guys how we're building a self-feeding knowledge management and AI assistant process for our users. I hope it was helpful and interesting for you. And if it was, please stay tuned and bear with us and keep on watching the podcast. Thank you so much.